Let's take a look at the varying levels of difficulty when it comes to partial fractions. From easy all the way up to brr. You definitely want to stick around for this one, because I can guarantee for normal A-level math students, you've probably not seen one like this before. So I'm going to show you guys some tricks you can use it as well in part A and part C. So you don't want to miss it. For part A, partial fractions. What is the process of partial fractions? Well, in a nutshell, partial fractions is the opposite of bringing fractions together. So if we take a half plus a quarter and say that's 3/4, here we're just adding the fractions. Partial fractions is the process of splitting up that fraction to the original form, or the original question that was asked. All right? So, for the first one, we're literally saying what must have added together to make this fraction? Well, it would have been one fraction with the denominator of x plus 1 and another fraction with the denominator of x minus 3. Now you have to remember that when we do split things up, let me move this over a little bit. Well, I don't even need to write part A. When we do split things up, you might be wondering, okay, what goes on the numerator? When we split up a fraction, the degree of the term in the denominator, so x plus 1, the degree of that is 1, it's power 1. The degree goes down by 1 degree. So go down to a degree 0, which is a constant term. We'll just say that's A. Then over here we have x minus 3, B. This means equivalent. Equivalent meaning any x value that you substitute in, both sides have to be equal to each other, which is what we're going to use here. Right, the next thing we do is we bring this together and compare the numerators, because when we cross multiply and bring the denominators together, we're not going to compare the denominators, are we? Because they're both going to say the same thing. So we're going to look at the numerators only. We're going to get 5x plus 1 is a times x minus 3 and b times x plus 1. Now remember, we can substitute any x value. All we do is we now sub in an x value that gets rid of either the a or the b. So let's start off with subbing in 3. Yeah, remember, any x value you sub in, both sides are always the same. So when x is 3, you get 5 times 3 plus 1, which is 16. That disappears. 3 plus 1, 4b. So b is 4. Then we're going to sub in x is minus 1 to get rid of this one. Minus 5 plus 1 is minus 4. Then we get minus 1 minus 3 is minus 4a. So a is 1. And there's your answer. I'm also going to show you guys a quick way of doing this. It's known as the cover-up method. And I only recommend you use the cover-up method when the denominators are not, well, are linear. Yes, there's no powers on them. If that said x plus 1 to the power of 2, just forget about the cover-up method. Okay? How does the cover-up method work? You go back to this. If I want to find out what a is, okay, if you want to find out what a is, you first say what would make this denominator equal 0. Yeah, well, to make this equal 0, x would have to be minus 1. Okay? Then you cover up x plus 1 on the other side. Okay, so we cover up, cover up. And then what's left, you substitute minus 1. So 5 times minus 1 plus 1 over minus 1 minus 3, which is minus 5 plus 1 is minus 4 over minus 4 is 1. Look at that. Yeah? Now, you need to show all this working if you're going to use it in the exam. Okay? Because you can't just say A is 1. All right? Show some working. And for B, what makes that denominator equal 0? X is 3. Cover that up over here. And we're going to sub in 3. We're going to get 5 times 3 plus 1 over, what is that? 3 plus 1. Which is 15 plus 1, 16 over 4, which is 4. Boom. Same thing. All right? Sweet as a nut, mate. Let's move on to part B. Medium. Now here it's a slightly more tricky one because we have squares in the denominator. And we have to think, okay, how do we break up terms that have been squared? Now, what some students think at the beginning is that we're going to split this up into a over this and b over this only. But that's not true. Because say I gave you what I gave before, 3/4. And I said, what must have added together to make 3/4? Well, you might be thinking, okay, it can only be something over 4. But that's not true. It's not just something over 4. You wrote it as 3 plus 1 or 2 plus 1. But that 2 over 4 split up into 1 over 2 and 1 over 4. All right? Now, the way we think about this and what's actually happening is we're thinking about prime factorizations. 4 is not actually 4. It's 2 squared. And that can be broken up into 1 over 2 and 1 over 2 squared. So yes, you take into account the same squared bracket, but you also take into account the linear version without the squared. So same thing here, that denominator of having a square is going to have that, but also, so that's the equivalent of this one, but also it's a linear version without the squared on it. All right? So with that in mind, let's go ahead and split up. We have x squared over x minus 2, x minus 1 squared. It's equivalent to the a over x minus 2. And then we're going to have b over x minus 1, yeah, the non-squared version. And this is why we only take into account b, because you might be saying, wait, that's x squared. Didn't I say it goes down by 1 degree? That's true, but because of the way the partial fraction works, we only take into account the non-squared version because we take into account the linear part. Yeah? So we take c over x minus 1 squared. Okay, so it's only about this. It's factorized into a linear. It just has a squared around it. Okay? But stay tuned for the Brr version. Now we do the same thing. Now students always make mistakes when bringing everything together. Yeah, they just times through by everything basically. How do you do it? How should you view this? X minus 2, x minus 2. This denominator is missing this one. So you need to times top and bottom by this. So we get a lots of x minus 1 squared. B, it has x minus 1, but it's not x minus 1 squared. So you'd have to times top and bottom by x minus 1. Yeah, so then it's x minus 1 squared, but it's also missing the x minus 2. And then C has the x minus 1 squared, it's just missing the x minus 2. All right? Now we can substitute in our values. I'm going to sub in x as 1. We get 1 squared. Now subbing in 1, that goes, we're left with this. 1 minus 2, which is minus 1, C. So C is minus 1. Then we're going to sub in x is 2. Subbing in x is 2 is going to get rid of this and this. We're left with, 2 squared is 4. 2 minus 1 is 1. 1 squared is 1. So we get A. There you go, that's done already. Now the question is, how do we work out the B term? Because the B term, we've already subbed in 1 and 2, right? Well, you just default to something else, all right? Remember what we said, the equivalent symbol is telling us that you can actually sub in any x value you want. You don't only have to do 1 and 2, you could have very well done this with 5, 6, 7. You would have had a bit more solving to do, but it will get you the right answer. Eventually you would have to solve simultaneously, but ain't nobody got time for that. Which is the next easiest option to choose? 0. Okay, we've done 1, we've done 2. Let's go with 0. 0 squared is 0. Here, 0 minus 1 is minus 1 squared is 1. A. Plus. When you sub in 0, you get minus 1 times minus 2 is 2. B. Then we have 0. Minus 2C. So it's not plus anymore, it's minus 2C. Sub in the values. 0 is A, which is 4, plus 2B. Minus 2 times minus 1 is plus 2. Add those is 6 minus 6. B is minus 3. And there are all of our answers. And if you want, you can rewrite your whole expression with those terms. All right, so that partial fractions is done. All right, third question, which is regarded as a hard question. I don't think it's that hard, to be honest. It's just the same thing with extra steps. We have 2x squared over x squared minus 16. Now the issue with this is, remember what I said, to do partial fractions, the degree of the numerator needs to be less than the denominator. And the key word there is less, not equal to. This is an x squared and this is an x squared. That's not allowed. We can't do partial fractions there. So what we're going to do first is long division, because this is an improper algebraic fraction. All right? It's got nothing to do with the fact that if you sub in different x values, it might turn into a normal fraction. That's not improper. Algebraically, it's an improper fraction. So what we're going to do first is we're going to do our long division. Okay? So we're saying, how many x squareds minus 16 go in to 2x squared? Okay? How many of these go into these? X squared times what is 2x squared is 2. Now you should only have to do this once, but if that was like an x cubed, you would actually have to do it twice. We multiply 2x squared, 2 times that is minus 32. Now when you subtract, guys, this is where the mistake comes, is these cancel and then they just write minus 32. But be careful, this is a plus 0. You're doing 0 minus minus 32 is actually 32. All right, so this fraction is 2 and 32 over this. But then you do partial fractions on this. X plus 4, x minus 4. And now you guys are well equipped to use the cover-up method, which is what I'm going to use. So 32 over x plus 4, x minus 4, a over x plus 4, and b over x minus 4. I want to find a. What value of x makes this 0? It's minus 4. Cover it up. I get 32 over minus 4 minus 4, which is 32 over minus 8 minus 4. Why is this the hardest part of the question? 32 divided by 8 is 4. So minus 4, yeah. And we're going to do, for b, what makes that denominator equal 0? X is 4. Cover it up. So we get 32 over 4 plus 4. 32 over 8, which is 4. And there we go. Our answer is 2. Now I'm going to write the positive one first. So 4 over x minus 4. And then we're going to say minus 4 over x plus 4. And that's your partial fractions for that medium type question done. And then we get to the brr version. It looks simple, but why am I saying it's the brr? Let's take a look. Obviously, we first have to check if it's an improper algebraic fraction. Okay, is it? The answer is no, because in the denominator it's degree 4 and on the numerator it's degree 1, so that's all good. So we can go about factorizing. How do you factorize something like this? Is difference of two squares. A bit of Dari action. So we get 1 plus x squared, 1 minus x squared. So we're going to get 4x over 1 minus x to the 4 is 4x over 1 plus x squared, 1 minus x squared. Now, I can keep factorizing that using dots, but I can't factorize this. And that's the problem here. This is what makes this the brr version. So we get 1 minus x, 1 plus x. How do we split this up? This is not the same as this, because the squared is on the x. This is degree 2. This, by partial fraction standards, is degree 1. It just has a squared around it. This does not have a squared around the whole thing. It's around the x only. So when we apply the partial fractions, the numerator is going to go down by 1 degree. This is power 2. The numerator is going to be power 1, which is linear. But when it comes to linear, it's not just ax. There could be a constant term as well. Ax plus b. This is nice and simple. C over 1 minus x. And the other one, d over 1 plus x. Let's do our comparison of numerators now. This has this. We have to times top and bottom by 1 minus x, 1 plus x. So we get ax plus b times these two. But I'm just going to say it's 1 minus x squared. It's just going to make life easier for us. plus c. That has 1 minus x, yeah, but it's missing 1 plus x squared and 1 plus x. And d has 1 plus x, it's missing 1 plus x squared and 1 minus x. 1 plus x squared and 1 minus x. You guys can see that? Just about, mate. Just about. Okay. But anyway, 1 minus x, yeah? We're going to do the same process for now. Okay, we're going to sub in x values and see what we can figure out. Here I can sub in x as 1. I get 4 is equivalent to. When I sub in 1, that just gets rid of this whole thing. That's great. All right. When I sub in 1, this goes as well because that 1 minus x. We're going to be left with this. We're going to get c, lots of 1 plus 1 squared, which is 2. 1 plus 1, which is 2. Just making sure I've done that right. Yeah. So c is uno. Should we do minus 1? 4 times minus 1 minus 4. Now with minus 1, what's going to go? With minus 1, it looks like it is just going to be this one. Damn. That's making this even tougher, right? It looks like we're going to have to substitute in multiple values. Actually, no, sorry, this goes as well. What am I doing? I'm bugging out. Because when you square minus 1, that becomes 1. 1 minus 1. Okay, that goes. Thank God. So that's going, and that's going. We're just going to get the d term. So we have d. Lots of. 1 plus 1, 2. 1 minus minus 1, 2. D is, so that's going to be minus 1, isn't it? Now, once we've done these, there's multiple things we can now do. One of which is we could expand everything and compare coefficients. That's if you're doing further maths, most likely you'd do it that way. But if we're doing normal maths, personally, I think the best way of doing this is to just, again, substitute in values, yeah, to find the ax and b. Because we have now exhausted all the options that find c and d, but both of those options end up making this 0, which is not going to help us find ax plus b. So we're going to default to what we did over here. All right, so let's do x is 0. A nice number to use indeed. Okay, when we sub in 0, that becomes 0. It could be nice actually because the a actually disappears. All right, I think there's a good choice then. So when x is 0, boom, that's gone. We're left with b. Then here, when that's 0, we just get 1. Cool. C lots of. 0, 0. 1 times 1 is just c, which I've got. Over here, 0, 0. 1 times 1 is just d then. And c and d are 1 minus 1. 1 minus 1 is 0. Bang. B is 0. Nice. It's usually the case. Not usually the case, but it happens a lot to try and make one of these things 0. Now, the next thing I would personally do here, well, I don't know actually. Maybe we just sub in a value. So this is gone, right? I was going to say now I would probably expand things and compare the coefficients, but I don't even think that's the nicest thing you could do. I think you just sub in another value. We've done 1, we've done minus 1, 0, 2. Should we just sub in 2 and just see what happens? What would you guys have done? 4 times 2 is 8. A times 2, 2a. 1 minus 2 squared. 1 minus 4, so minus 3. Plus c, which is 1. Times 1 plus 2 squared, so 5. 1 plus 2, 3. And d is minus 1, lots of 1 plus 2 squared, so 5, And then we get 1 minus 2 minus 1. So we get 8 is minus 6a plus 15 plus 5. Bring that here, move the 8 over. So I get 6a, 20 minus 8, 12. A is 2. Beautiful. And just because there's a tough question, I want the satisfaction of writing the answer, okay? Allow me. So I get 2x, remember b was 0, 2x over 1 plus x squared. C is 1 over 1 minus x. And d is minus 1. Minus 1 over 1 plus x. And that is our partial fraction decomposition. And there you go, guys. The 4 varying levels of difficulty. This is obviously a really tricky example. Further mathematicians have an even more difficult type of decomposition where they have 2 of these being non-factorizable. So, yeah, guys, if you learned something today, I would really appreciate if you hit that like button, subscribe for more maths content. If you want to submit your own questions, you can go to the Lungang Reddit where my community will help you out as well. And if you're interested in my A-level maths courses, there is a link to that in the description as well. I'll see you guys in the next video. Nice.